Okay, this is a video for number 10 on 1.6. All right, so let's talk about, this is a function that we're going to talk about what happens when I have a function that's not invertible. Is there a way that I can make it so that I can find the inverse? And it's called putting a restriction on the domain. But first, let's kind of get a feel for what's happening with this function. So in part A, it's saying find h of 5. So I plug in 5 for x, and I get 5 minus 3 squared, or 2 squared, which is 4. But then in part B, it's saying, okay, given that this is a parabola, which is going to have some symmetry, find another value that I could plug into h that I would get the same output as when I plug in 5. So in other words, what's another value when I plug it in for x that I get an output of 4? And you'll find if you plug in 1, I get 1 minus 3 squared, or negative 2 squared, which is also 4. And that's a problem for us because a function is not invertible if more than one input goes to the same output. Because remember what an inverse is. It flips the domain and range. So if there are repeats anywhere, in this case repeats in the range, then the flip of that, or the inverse, is not going to be a function. So we need that one-to-one correspondence in order for it to be a function. Well, it turns out we actually can restrict the domain of this function if we want to find an inverse. And how you decide to do that is you want to figure out, when you restrict, you want to make sure you include all elements of the range still. So if I look at this function, it has a range of 0 to infinity. Because something squared, the lowest is going to be 0, and then it's going to get infinitely huge. So if I think about a graph of this function, it is 0 when x is 3. So there really are two ways for me to restrict this, so I still include all y values 0 to infinity. One way is to restrict it greater than or equal to 3. So I could say, for the domain of h, I could say, let's restrict it 3 to infinity. The other thing I could do is the other way. What if I restrict it negative infinity to 3? And those are the two options I have. Again, I want to make it so that it is invertible. And indeed, both these sections would pass that horizontal line test. And I also want to include all possible y values. So in this case, I want to include 0 to infinity. So that was really the only two possibilities. But now, based on this restriction, I'm going to have a specific inverse. And something that might be helpful is thinking about what would be the domain and range of my inverse. Because remember, if you found the correct inverse, the domain and range should totally flip. So we said the domain with our restriction is going to be 3 to infinity, and the range of that, as we said, was 0 to infinity. That means when I find the inverse, if I do it correctly, the domain of the inverse should be the range of the original, and the range of the inverse should be the domain of the original. So let's go about finding our inverse and making sure that works out. So remember, to find an inverse, we are undoing the function. So let's go back to the original function and list the steps we would have taken to find the function. First, we would have subtracted 3, and then we would have squared it. So to undo that, we're going to do the opposite of squaring is square rooting. That's when we notice, oh, wait a second. When I do a square root, I could do the plus or minus square root. So which is it going to be? That's what I have to decide, and that's what the restriction is going to tell us. So going to my problem here, I restricted it from 3 to infinity, which means I want the range of my inverse to be 3 to infinity. Well, that leads me to believe that I'm going to want, where's my undo button here? That leads me to believe that I want the positive square root of x, and I'll show you in a minute why. And the opposite of minus 3 is plus 3. And the reason I want the positive square root of x is, again, I want the range of my inverse to be 3 to infinity. And if I look at this, the positive square root of x coming out of that would be 0 to infinity, and then adding 3, then that would check out. So that would be great. However, let's do the same thing if we restrict it the opposite. If we restrict it negative infinity to 3, again, the range of the original is 0 to infinity, and let's write down what we want the domain and range of the inverse to be. It should be the exact opposite of, so domain of inverse should be the range of the original, the range of the inverse, so it should be the domain of the original. Okay, so when I find my inverse then, instead, because I want my range to mostly be negatives, again, negative infinity to 3, I want the negative square root of x. And then I'm going to add 3. Well, just like I did before, because the opposite of minus 3 is plus 3. And let's make sure that checks out, because you're going to do minus, and coming out of that square root is going to be 0 to infinity. And then when you multiply that by negative 1, it flips from negative infinity to 0. And that indeed will work. It'll be negative infinity to 3. So that's what you think about. So you have to keep in mind the opposite of squaring is going to be square root, but when you think about when you solve for something squared by taking the square root, it's plus or minus the square root. So you have a choice there. And the only way you're going to be able to decide is based on a restriction you have.